We shall begin this course with a module on discrete structures. Quite fascinating subject and finds applications in almost every area in computer science. We shall be focusing on discrete sets. For example, any finite set is a discrete set. Example, an integer array of size 100, integer array of size n, where n is fixed. You come across natural numbers, we come across integers. Natural numbers, we can list first number is 0. We don't differentiate natural numbers and the set of whole numbers. So when we talk about natural numbers, we start from 0, 0, 1, 2 and so on. Over here on one side you can list 0, 1, 2, 3. On the other side you can list minus 1, minus 2 and so on. So there are infinite sets which are discrete in nature, and all finite sets are discrete. By discrete, you get to observe from these examples that one can list first element, second element, third element, first element, second element, third element and so on. So one can list these elements. Listing of elements in a specific order, or you can enumerate the set. Enumeration meaning the first element, second element and so on. So in computer science we come across these sets. So what kind of sets are we interested in? As I mentioned before, the computer science is all about solving problems. So when we talk about problems, we talk about input. So then natural question is, what is the size of the input? That's one question. Second question is, how many inputs are possible? Next one, can we list all inputs? So questions like this we would be interested in when we talk about the input as such. For example, let's focus on the problem search or say sorting. Peculiar one. You must have seen this at various contexts, right? If it is a search problem, input is a comma x, and if it is a sorting problem, input is a. In case of search, you ask for is x belongs to a. In case of sorting, we say sort a. Now the question is, how many different it's an array, right? How many different arrays are possible? If it's an integer array, we ask for how many different integer arrays are possible, things like that. And we are interested in counting such a set. And we are interested in listing all of them. How many different inputs are possible? Can we count? Can we list? So on one side, the subject as such will tell you the term discrete refers to these sets. And now the natural question is, are there discrete sets in computer science? The focus of this course will expose you to necessary mathematics with a strong connection to the underlying field. So we shall tell you or highlight at various points in time when we study a mathematical concept, we will immediately tell you that here is an application. And we don't just study set as a set or mathematics just as a mathematical tool or a subject. We also talk about its connection to computer science or where exactly such a set appears in computer science. One such immediate application is when we talk about search and sorting, we ask for how many different arrays are possible, can we count, can we list. So we come across these sets in computer science. These are discrete in nature. And you can list, here is a first input, here is a second input, here is a third input, and so on. That's precisely what discrete set is trying to picturize. Can you list the elements, first element, second element, and so on. So in some sense, if you look at this line, this is my first element, this is my second element, this is my third element, fourth element, and so on. And there are no elements in between. Okay, so which is why if you look at this as a real line, discrete set focuses on 1, 2, 3, 4, 5, 6, and so on. Okay. Now, natural question is, are there non-discrete sets? Are there non-discrete sets, or are there continuous sets? Answer is yes. The set of real numbers is an example of a continuous set. Continuous set, there is no listing, one cannot list, there is no enumeration. So one cannot talk about first element, second element, and so on. For example, if you say first element is A1, A2, A3, A4, and so on. For example, you say first element is 1, second element is say 1.5. Now you get to see that there is an element in between, which is 1.1. If you say first element is 1, second element is 1.1, and like that, then which is not correct. You get to see that between 1 and 1.1 you can have 1.001 before you get to see 1.1. In fact, if you take any two real numbers, say A and B, you get to see that A plus B by 2 is also a real number. Again, if you take A and A plus B by 2, you get to see that again A plus B by 2 is also a real number. If you take these two to be real, then this is also a real number, which is, between these two. If you take these two, then you see that A plus B by 2 is also a real number, which is between this and this. Which means there is no listing possible. If you say here is a first real number and second real number, and average of that is also a real number, and like that one can keep arguing, but such a set exists. One such example is real numbers. Now, are there continuous sets in computer science? Are there sets that cannot be listed? Are there sets that cannot be enumerated? The answer is yes. In fact, set of problems in computer science is an example of set of computational problems, something that you wish to solve using computers. Set of computational problems is an example of a continuous set. Why this is a continuous set, why not it is discrete, all that we shall see in detail as part of the course. But just to touch upon that, yes, we get to see discrete sets in computer science. We also get to see non-discrete sets in computer science. But as part of the course, we shall highlight more on discrete sets, its properties, and some kind of counting problems, proof techniques based on that, and all that we shall kind of expose you as part of this course.